Hey, what's up YouTube? It's VitoPlayer1011 here, and today we'll be introducing the derivative, specifically the definition of what a derivative is. So before we get into what a derivative is, first we have to go over what a slope is, and this will give you a hint to what a derivative aims to do. So first let's look at this line over here. It's a straight line, and we're going to want to find the slope of this line, and it should be pretty easy because the slope is consistent. So before we get into that, what is a slope? The slope, by definition, is the change of y as you move along x. So I'm going to label the slope m is simply, by definition, the change in y as you have the change in x. So what this question, what the slope questions basically is, how fast does this line change? Now, let's say I had a line that looked like so. The slope for this would be much larger because, as you can see, as you move a little bit in x, y goes up by a little bit on the purple line. On the blue line, as you move a little bit in x, it actually goes up much more. But that's unimportant. This should be review. Let's rewrite this now. So let's say the line is given by f of x. So what would the change in y be? It would be f of x1 minus f of x all over, sorry, that line wasn't straight, x1 minus x. Now let's make things a little bit simpler. I'm going to replace this change in x by, I'm going to replace this change in x with h. I'm going to substitute h in here. So what's going to happen is this is equal to f. Now, since I'm replacing h, I'm just going to take this up here in a second. x1 minus x equals h. So that means that x1 is equal to x plus h. And this should make sense because h is the change in x. So we're going to end up here as the initial x plus the change in x, or h, minus the initial f of x. And then in the denominator, we replaced x1 minus x with h. Now I'm going to draw a graph down here. And this graph will show something, and we're going to find the slope of it, basically. Now, this will be blue because I like the color blue. Let's say the graph, it shouldn't be a line, it should be a pencil, my bad. Let's say the graph looks something like this. Something a little bit crazy. And I want to know what is the slope at a specific point over here? Now, what I want to do is basically draw a tangent line to this point. So first I'm going to start off over some small distance from here to here. Then I'll get a bit closer from here to here, and a little bit closer until I get a line that is perfectly tangent to that point. And that'll give me the slope at that point specifically. Now, as you can see, unlike this, the slope is the same everywhere throughout this line. On this line, the slope is a little bit different. For example, at this point, the slope looks like this at the top. Over here, when it's going down, the slope looks more like this. Going up, the slope looks like so. So basically, this is the general definition of what a slope is over here. But I want to know what happens if this change in x over here, this h, gets very, very, very small. Instantaneous small, in fact. So we're going to rewrite this as a limit. The limit as h, approaches 0 for this entire limit, f of x plus h minus f of x over h. And in short, this is the definition of the derivative. I hope you understood that, and if you have any questions, leave them in the comments below. I hope you will join me tomorrow as we go into a little bit more of a deeper explanation of how to use this definition of a derivative. Thank you for watching.